Hi guys, uh, you're welcome to today's class. Today we're going to be discussing about decision tree and how it relates or how important it is in data science and then what it can be used for. Firstly, let's explain what decision trees are. Decision trees gives a graphical representation to all the solutions to a problem, to a given problem, and how you arrive at at those most suited solution. So in machine learning, decision trees is a type of supervised machine learning that is used to categorize and predict information. What are the types of decision trees in real life? So probably you've called your bank uh, toll line before, and they ask you, in order to continue, press 1 to speak to an agent in English, or press 2 to speak another language, maybe Spanish, or 3 to speak Portuguese. When you press any of the numbers, say 1, it tells you for credit card related issues, press 1 again. For account opening relations issue, press 2, and like that. So it's based on the figures that you type and press on your phone. The system knows where to direct you to, and it's just an example like this where you have on the screen. The final decision is represented at the bottom here, whether you should solve or not solve. So in order to decide or to arrive at this final decision, there are some few things that needs to be considered. So is there a swell? No. If there is no swell, then definitely you're not solving. If there is a swell, is there high wind or is there low wind? If there is low wind, you go to surf. If there is high wind, you consider the kind of high wind. So based on that, you decide whether not to surf or to surf. Another example is here where you're considering whether you should accept an offer or decline an offer. So if the salary of the applicant is between 50,000 to 80,000 of the job you are considering, is the office near your home? If it is yes, do they provide cab facility? If it is no, if the office is not near your home, then you decline the offer. So these final decisions are referred to as the leaf node, while here is called the root node. So in essence, decision tree use should be able to do classification and regression. Then in some complex instances, how do you decide which of the criteria or attributes to use in classifying your data or splitting the data, let's say? So that is where science comes in. So in order to determine the best split points, you can either use your entropy or you use Gini. So entropy is how pure a sample is. Uh, Typically, it's represented with 0 to 1. 0 means the purest. Then you hear terms like information gain, which is the inverse of entropy. So it recognizes the set of attributes that is most important in distinguishing a data set. So this is done for you by the algorithm that you choose to use, and you're going to see that in a bit. So we've talked about what a decision tree is, the application in real life, the keywords or the terminologies that are used in decision trees. We talk of entropy, we talk of Gini, we talk of information gain. Gini is the probability of classifying a feature incorrectly. So attributes with the lowest Gini uh, have more importance, or you find the attributes with the highest information gain. So essentially, that's what your algorithm does. So this is the workflow that we're going to be using today. As we move on, you can refer to this workflow at any point during the video. Without further ado, I've launched my Jupyter Lab, as you can see on my screen here. So I'm going to open a new Python 3 kernel. The data that we're going to be using today is the same as the one we used in the first class where we did data exploration. So I'm not going to waste your time to further examine the data here. We're just going to go straight to decision tree. So if you're interested in pre-accessing what the data is, you can refer to the data exploratory tutorial, which is actually unrelated to this one. So if what you're interested in is purely decision tree, you can come with me on this. So firstly, let's import our libraries, NumPy and pandas. Then we we import the file, which is this diabetes prediction data set, and we'll try to examine the first 10 rows in the file. So the same columns as the ones we've seen before. So the next step when you're doing decision tree classification or prediction is we've defined the data that we want to use. The next thing is to bring in the train test split, which is from scikit-learn. Then we'll bring in accuracy score in order to know how accurate our predictions are. And then value score as well. So these are the three libraries I'm talking about here. You just import them. The next thing is to split the data using these tests, train test split. So we want to split our data into X and Y. So this variable is called the X train, and we're going to use these columns. We have to ensure that the columns we're using from our file are not object type. They are not containing strings for both the X and the Y axis. So this is our target variable here, the Y train, and we are just going to use diabetes. As you can see here, if you don't have diabetes, you labeled as 0. If the person's got diabetes, is labeled as 1. So that's our target variable, and so that's what we have defined here, X train and Y train. We execute that. The next thing, as I've said earlier, is to split the data, and it's very easy. This parameter of train test splits, you have to give it your X train, your X test, the Y train, and the Y test. So those are the 4 variables that are required. And then you tell it X train, Y train, which is your X and Y axis. The test size is saying that it should use 20% of this data in your data frame for testing, and 80% that is left to train the model. Okay, so it's going to train the model with 80% of the data. Then the data frame to use is df underscore diabetes in diabetes column. So we've splitted the data. The next thing is to import the decision tree algorithm, and then once we import it, we fit our training data into it. And here is how. From sklearn, we are importing decision tree classifier. Then we set a new variable. We can call it CLF in this case, CLF classifier. You can name it whatever you want. And this is the criteria that we're using, CCP alpha. So we've instantiated this decision tree classifier here. And next we'll fit our training data into CLF. So this class, the decision tree classifier that we've instantiated here as CLF, we fit the X train and Y train data into it. Then we will try to make predictions based on the model that we have trained. So we're saying now that prediction is equal to CLF.predict. So we're asking the variable to predict the X tests using the training data. So what this means is that using your model that you have trained with 80% of your data frame is going to predict the Y value of the test data. So let's see what prediction looks like. It's giving you this array. Again, we can also, it's not just the test data that we can use it to predict. For the purpose of testing, you can also predict the training data and see if it works. And now that we've predicted, how do we know that what we are predicting is actually worthwhile? We'll use our accuracy score in order to know that. So let me show you. First, we have to import accuracy score. Okay, I think we've done that already. So let's instantiate the accuracy score. For accuracy score, we're using Y tests and predictions. So it tells us that the prediction is 97% correct. So again, let me explain. We instantiated a decision tree classifier algorithm here as CLF. Now we'll fit our training data into CLF, and we ask the training data to predict using X test the value of Y as prediction. Now this prediction, we are comparing the actual value, which is the Y test, with the predicted value, which is in prediction. And it tells us that comparing those two values is 97% accurate. Let's do something basic here. For X train that we've predicted as well. So compare Y train, the actual value in Y train, with prediction true 2. Don't forget our prediction 2 is using X train. So you compare Y train and X train and then print the accuracy score. Again, the accuracy is 97%. Let's try to see using confusion metrics, what we are going to have. So from SQLN, we are importing confusion matrix, and then we are imputing y-test predictions. Then it should label and index the data as this. So the confusion matrix is giving us these results, giving us the actual years compared to the predicted years, and the actual no compared to the predicted no. So it looks good. It looks good. Now we may want to see the tree itself. And for us to see the tree, we need to know the feature names. The class name you can manually define. So let's see the future importances in order for us to, before we make the plots. So first, we define future names to use the columns in xtrain. Let's ensure that the future names are what we actually want. So this gives us all the columns in xtrain. Now we do clf underscore feature importances. And then let's define our future importance after that. Yes, so like I was saying, we want to see the feature importances. Here we've seen the feature names, which shows the columns in our training model, xtrain. The feature importances shows us the most important of these features that we selected or that we've given the model. Let's see that briefly. So it's saying of the 1, 2, 3, 4, 5, 6, the 6 features, only 2 of these are so important to predicting diabetics. And of the 2, this HbA1c level is the most important because it carries more weight. So in clear terms, this is what clf dot feature importances is doing. So it's showing us the feature importances of the classified model. That's the model that we've trained. It's showing us the feature importances of them. So this line is creating a panda data frame using the trained classifier, the feature importances of the trained classifier. So we'll create a data frame with it. Like I told you, the essence of this is towards plotting the decision tree diagram. We just want you to see. Now if you look at feature importance, it gives you this indexed table data frame. So you have the values ranging from the most important to the least important. Now let's see. You may have a data frame that is so big and so many features in them. You may just quickly want to see only those values that are greater than 0. Then let's examine the features. We've created a variable now, so it gives you just the columns with feature importance. Yeah, as you can see, you have 0, 0, 0, 0 in this one, so it has removed them. It's giving you only values that are greater than 0. All right. Let's see how important it is. So essentially, to determining the split points in your decision tree, you are going to, the data is going to be using these two values because they are the most important for it. So from scikit-learn, for us to plot the data, again, this bar plot is showing us the relevance. HbA1c level, it's far more relevant than the glucose level, while the others are just non-important. So in order for us to plot the decision tree, let's import scikit-learn and tree from scikit-learn, and then we import pyplot from matplotlib, and that's all. I'm going to bring in my code to plot for me using the trend classifier. It's going to classify whether it's diabetic or not diabetic. Use font size of 12, and then it's going to use the feature names that we've defined here. The class name, you can put any string that you want here, and then you run it. It gives you the tree. So it's telling you that the algorithm is using Gini here. As I mentioned in the beginning of the video, you could use Entropy. And these are the samples, and it's giving us these as the root node, and the split point is glucose. Of course, you've seen in the data that there are just two important features, and it's arriving at its leaf very early here. So that is about decision tree. I hope this video meets your expectation. If there's any parts to improve on, kindly let me know. In the meanwhile, please subscribe and like the video. Thank you for